Hi, this is Manas here. So, I'm just trying to share my screen. So here is my screen. Okay, give me a second. Let me share my screen. Okay, so this so I'm a developer by itself. So I did the entire work in Pandas in Anaconda notebook. Right, the scope of the work is basically to evaluate a data set and to build a model around it. So in this project, I have divided that work into like modularized components, right? And I have used the data set which was provided actually, which consists of a combined cycle power plant data, which uses combination of gas turbines, steam turbines, and heat recovery generator system to generate power. Right, the data set consists of temperature, ambient pressure, relative humidity, exhaust vacuum, um, and net hourly electric energy output. Right, and this is a target variable. And we have to analyze this data and pretty much build a model around it and evaluate various models and pretty much get the accuracy around it. Right, that was the whole task. Right. Now, what I did, just to start off with, I imported all the libraries which needed for um, data processing, encoding, feature scaling, for all the models which is required. I will go through various models which I've used, right? And that was the various libraries imported. I also try to use TensorFlow, but the entire models from libraries were imported, right? Here I'm importing a data set. I'm building the X and Y values. So X values are pretty much the values actually apart from the target variable. If you see these four values like temperature, AP, RH, and V are the variables, and the P is used as a target variable. So this code helps us to divide the X components and Y components. X component are the first four variables. Y is the target variable. So I've just eliminated the X and Y variables. So that gives us the X and Y variables out here right now. Reading the data sets, just got to see that it is P is a target variable, ATV, AP, and RH. As you see, it resembles temperature, ambient pressure, humidity, and vacuum. Other and electrical energy output P is the target variable, right? Now inferences out of this actually temperature is like ranging from 1.81 to 37.7. Ambient pressure is ranging from 992 to 2033. Relative humidity is ranging from a range of like 25 to 100. Exhaust vacuum is related to from like 25 to 81 centimeter, right? So it's a pretty normal data set. Shape of a data set is like 9.968 rows and 5 columns, right? Uh, Now, I want to identify the null values of the data set, which is a part of ADA, explorative data analysis. We went and described the data set. We went through like count, mean, standard average, which is a standard process for like going through EDA. Then I derived a correlation map. Correlation map helps you to identify the relationship between various components of the um, of the data set, right? So if you see AT and P are inversely related, RH and V are also inversely related, which is like 0.54. AT&P, the value is like 0.95 over here from which is negative, which is like inversely proportional, right? This uses data set for like model training, right? I divided the pre-X train and X test and training into like 80-20 split. So the test size, if you see, is like zero point 0.2 and random state is 0. And so I divided it to the test and train and data set into 20-80 ratio, right? And we split the models into 20-20 ratio and pretty much train the model accordingly. Now, the various models we are using, right? First of all, since we were seeing that the data is like inversely related towards certain components, we use linear regression, right? Now, first model is linear regression. The standard process is probably testing a simple linear regression model on a training set, and this is the code for like training linear regression. And finally, we're like predicting the test results, right? And finally, evaluating the performance. If you see, if I get a performance metric, it has got a 90% accuracy on like the R2 score, right? That is the performance of the linear regression model. Finally, if I visualize the test results between AT and P, you get a linear regression graph, right? Which is like it's like a inversely proportional graph, right? So that's the analysis for linear regression. If you go into multiple regression, you have train test values, similar process, 80-20 ratio split, evaluating the train model performance. The model performance comes to 93%. R2 score, then I go to polynomial regression. Then I do the similar process out here, actually to go into polynomial regression models, evaluate the score, performance comes to around 94%, right? Then I go to support factor regression model, right? Actually, when I got it, I went to certain errors over here, but I pretty much can see that it is performance comes to around 93, 94, around 92 to 93% or less than that, right? I went into decision tree model also, similar process out here, and went into the evaluated training performance. The performance came to 92% auto score. Went into random forest model, which is the most popularly used model, right? Same technique over here, 80-20 split, predicting the test results, evaluating the performance. Performance is best over here by the 96%, right? Then I went into ANNs and all that. Actually, I tried to do a TensorFlow Keras model. We went into certain errors, but I think going into ANNs and pretty much going into performance metric of ANNs, actually that goes into performance of around 90%, right? When I finally evaluated the performance and conclusion, we finally concluded that random forest model has got a 96% accuracy, right? Which has got a best R2 score, which makes us believe that a random forest model is the best model to go for it. Now, this was a pretty vanilla data set, actually, where there doesn't have any null values, right? And we went into random forest model. We explored into various model techniques, and finally went into a strategy of like building out that random forest model is the best model to go to right now. Thank you.